Hi, and welcome to Allen High School's discussion of chemical bonding at the APIB level. We're moving into our discussion of ionic bonding, a little bit longer than both network covalent and metallic. And much of it will be a review. Not all of it, but much of it will be a review of pre-AP. Ionic bonds involve the transfer of electrons from an atom of low electronegativity, likely a metal, to an atom of high electronegativity, likely a non-metal. Okay, the metal atoms, remember from pre-AP that the metal atom is the loser. Metals are losers. They will lose an electron to become a cation. And this process or this substance is said to be oxidized when that occurs. Bring in some of our terminology from pre-AP. A nonmetal, in the case of ionic bonding, gains an electron or electrons to become an anion, and this is then said to be reduced. The nonmetal is said to be reduced. Now, a way to remember this, I got this trick from Ms. Marusik, cation ion, Ca positive ion. And then the anion is a negative ion. So that might be a way for you to make sure you remember those two. Now, reality is there's not really this sharp boundary between transfer of electrons forming ions and sharing of electrons. It's really a continuum, and that's what's represented here. And we use the difference in electronegativity to discuss that. And I like to use the analogy, maybe because someone near and dear to my heart happens to be ADD. But let's take a look at this as a continuum in life. That, we have somebody that's a little bit ADD, and then somebody else that might be what is termed obsessive compulsive. And the reality is there's a continuum there. There's not this hard and fast boundary. In fact, many of us joke about, oh, I must be being a little ADD today. Oh man, that was an obsessive compulsive thing to do. And that is a reality. We all have varying degrees of tendencies in those. But somebody who makes these decisions, I don't know, but somebody has formed a boundary where they say, you know what, we're going to classify it as ADD because it's hindering the person's ability to function well in school or the home life or in their social life or work life. And again, who defines what normal behavior is, but we won't get into those discussions. I'm just saying that these lines exist. And likewise with obsessive compulsive. But really, there's a continuum. And that's what we have with ionic. Along this continuum, at right about a difference of electronegativity of 1.7, it starts to display about 50% ionic function. Remember, structure determines function. So if it behaves functionally more like an ionic compound, then let's classify it as ionic. And so those are classified as ionic. So ionic is shown here with this transfer of electrons, and the boundary is about 1.7. All right. And if we look here, we have what's considered covalent, but it's unequal sharing, okay? And so this would be kind of an unhealthy relationship. One person's always the giver, one person's always the taker. This is a typical relationship where one does tend to give more than the other. And we use this, it might be hard to see, but let me show you how to write this. It's like you start writing a figure 8 and you stop. And that's the lowercase delta, and it means partial. So this is a full negative. This is a partial negative. And that would represent a polar covalent molecule. Okay, so this is down here below 1.7. So if this is 1.7 and above, okay, this is below 1.7. This would be that partial. Again, make the figure 8 and stop. positive, a partial positive. And that's called a polar covalent bond. Polar is opposing ends. Okay? This would be maybe analogous to a very healthy relationship in which both people are giving equally to the relationship. And this is usually considered to be less than 0.3 for your difference in electronegativity. All right, for that. And let me draw a number line to see if maybe I can give you a better guideline for that. Some students like this. And I think maybe that will help as we get into our next little concept here. So let's summarize, because we're comparing ionic and covalent, and then we're going to focus on ionic in these next few movies. So ideally, the max you would go is 4.0, right? Because fluorine is 4, and the lowest electronegativity in theory would be 0. So the lowest difference. So this is my difference in electronegativity, just the big one minus the small one. And then we would go down here, and this would be 0. So this is the 0 end. This is 4.0. And this is not going to be drawn to scale. I'm just going to put markers here. About right here is going to be 1.7. And up above 1.7, this is considered to be, we're going to classify it as an ionic bond because it has greater than 50% ionic characteristics, or it functions pretty much as if it's ionic. Down here, way down here, we've got 0.3, which is typically the boundary between, whoops, that's not a very good 3, there we go, polar covalent and nonpolar covalent. And then right in here, I can't really get the word in, would be nonpolar covalent. Now, just a heads up, we being scientists, and as you will as well, considered a CH bond to be nonpolar bond. Okay? Now, in general, what we have here, the further the atoms are away from each other on the periodic table, the more polar the bond is. So again, a carbon-hydrogen bond is considered to be non-polar. So count steps between the elements, and if you go up in period numbers, so as you increase period, or go up in period, so this is period 1, 2, 3, 4, okay? I would say if you have even steps, pick the higher one as the more polar. If there's a tie. Higher on the periodic table, not higher numerically, but higher up on the periodic table, it's the more polar. All right? So we're going to use a periodic table to rank the following bonds. And what you do is count blocks. So you want to count blocks without going diagonally. So count from one element to the other and don't go diagonally. And this is going to help you get this. For this, I'm going to take 4 steps. This was 6 steps. This was 1 step. This was 2 steps. Excuse me, 1 step. I looked at the wrong number. Sorry about that. I was looking at how I ranked it. My bad. Oh, Dina. Okay, 1 step. 3 steps. And 4 steps. Go look at the periodic table and verify you can do that. So now let's rank them. Remember I said the furthest apart is going to be the most polar. So that makes LIF the most polar. Now I have 2 that are 4 steps apart. But again, remember I said you want to go up in the periodic table, and since this was higher on the periodic table, more towards the top of the periodic table than was iodine, I predicted this would be 5 and this would be 4, right? The higher up you are, the more polar it is. It wins if there's a tie. Now again, then this 3 is going to be 3. Now we have a tie, but OF is in period 2, is in the second period, and SP is in the third period. So the higher up it is, the more polar it's going to be. So that's going to be a 1, and that's going to be a 1, or 2 and a 1. Now, one thing that I do when I count blocks is I skip the D, because the D block is pretty much very similar electronegativities. So skipping the D block, I'm just counting representatives or the S and P block. Now, if you look these up on an electronegativity table, you have one in your resource. Let's see if we predicted correctly. I was actually shocked that I predicted correctly. I thought I'd be off in at least one of them. These blue values are my difference in electronegativity. I just took the big one minus the small one. Keeping life positive here. 0.3, 0.5, 0.7, and 0.8. So we would rank these exactly the same as what we predicted. And very often, if it's a multiple choice, you're going to be much more likely to have to predict it than you are going to be to calculate it. Sorry, I should have put the star there. You're much more likely to have to predict it than to calculate it. So again, this was 6, this was 5, this was 4, 3, 2, and 1. Least polar to most polar. Okay? So you should be able to predict that. What I've heard somebody say is if you're looking at the most electronegative elements, if you think phone call, fluorine, oxygen, nitrogen, chlorine, this is the most, this is the second to the most, and I believe nitrogen and chlorine are neck and neck. They might be exact on that. So, okay. Now, I think that's enough for this video. In the next one, we're going to look at formula and structures. So until then, this is signing off.